output layer, which is a simple perceptron, right? So we are going to solve the problem using input layer and the output layer. So if you are having multi-layer perceptron means you will be having in between you will be having hidden layers. You can have any number of hidden layers, right? Multi-layer perceptron. So the concept was introduced by Nndl in 1957. This is a concept which is nothing but a concept mathematical model for our biological neurons. It is the simulation of our biological neurons. A mathematical model of biological neurons was developed in 1957. Okay, so you know very well what is perceptron. Anyway, I am again repeating you. You know the concept. What are the different five layers? I mean five concepts in perceptron or neural network. Input, output,
bias,
hidden,
bias,
and activation function. We know very well. So input layer is used for perceiving input from the environment, and the output of the input layer will be given to the hidden layers for computation, and the output of the hidden layer computation will be given to output layer. So in between what we will do, how will we calculate the output? Summation of input value with its associated weights. We knew it very well, right? So along with this we have to add the bias value, then we will apply activation function. You remember, right? We have seen this from all the 3 units, isn't it? So it takes binary inputs. Either it will take a particular data directly or it will take the output of another perceptron, right? So you have the first layer means it will take the data directly, right? So in between layer means the output of the first layer will be given to second layer. That's right. Either it can take data directly or output of another perceptron will be taken as input. Then bias of input, always the bias will be used as 1. Bias value used as 1. Okay. So links represent the synapses in a biological neuron. How a particular neuron is connected to another neuron. We are representing using this, right? So which is nothing but synapses links, which has a associated strength. Strength is nothing but in our terminology we are representing it as weights. Okay, so each synapses or each link has its associated weight. The weights cannot be same for all. The weights may be different. Got it? Got my point? Okay, the weight may be different. Okay, the output will be based on the input values. You know it, right? So based on the input value only we will compute. Input into its associated weights, we can able to calculate the output. So the output based on the inputs. The output value is commonly we will be taking the output value as 1 if the weighted sum we are calculating, right? Summation of x1 w1 plus x2 w2 and so on based on the neurons, number of neurons present in our perceptron. So if it will be 1 if the weighted sum is big enough. If it is very big means we will take the final output as 1. Otherwise we will take it as 0. Already know concepts. Just we are recollecting in this history part, right? And we can able to represent and function or functionality, not functionality using the perceptron concept. Okay, so concept of perceptron. So initially inputs can be binary, either data or it can be the output of previous layer. It can be the output of another perceptron, and bias value probably 1, and the links here are represented with different strengths in our terminology, different weights. Okay, the output of each layer will be based on the inputs and its weights, and then the final output can be 1 if the weighted sum is very big. Otherwise it is the output value will be 0. And we can able to solve more complex functionalities using the perceptron. Got it? Right. So how anyway in any machine learning, in any neural network, we have two different phases, right? You are going to solve a problem. You are going to create a model. For that model, you should have a training phase and also testing phase, right? For training, what is the main concept we are using means learning. So idea by Hebb. We have seen in the second unit, right? Hebb's rule, right? So the idea is nothing but forming the synapses, forming the links and changing the strength. Forming links means we have one layer will be in input layer. If we have two neurons, means this two neurons will be connected with all the other neurons in the hidden layer. Am I right or not? All the links will be available. So suppose if you have the value, you are getting the output which is not equal to the target value means we are going to change the strength, change the weights. So that is what given. Idea by Hebb, we are forming the links between different neurons and providing weights so that we are so that the model is learning. So how the perceptron learns means by using the Hebb's rule. By using Hebb's rule. Okay. If you are creating output from one neuron to another neuron, if the output is very low, means we have to update the weight. We will be updating weights, right? So we have to update the weight by increasing it. If it is very high, then the targeted output means we have to reduce the weights. Okay. So basic concepts of perceptron, and this is the learning of training phase. Perceptron algorithm. So how we are starting with the random weights. Initially we will have a random weights between each and every neuron links. Okay. Do you remember when we will update the weights? We have solved the problem for perceptron, right? We have solved, isn't it? So when did we update the weights? Either in the starting or at the ending during the back propagation. During back propagation. Why? So initially we will be solving. If it is not matches the target means if we will be getting some error or loss, so that we will update the weight values, right? So that is what. So initially we will start with the random weights only. With the random weights, we will do the computation. Okay, computation in the sense. So for example, computation in the sense, what is the value of output y? Y is equal to y is equal to, this is W1, this is W2, X1, X2, input into its weight plus next input into its associated weight. So summation of xi into wi. Do you remember or not? Which is very simple, right? So initially we are taking random weights. Then we are training our model by computing the output of the perceptron. For example, we are having this means the output will be 1 into 0.2 plus 2 into 0.3. So this is what computation part, right? So compute output of the perceptron. We have a target output, right? If the actual output is not equal to the target output, that we have to decrease the weights. This is what our target. Target is very low, but we are getting the actual weight as 1. So we have to decrease the weights. On the other case, vice versa. Suppose you are having target is equal to height. 1 means not exactly 1. 0 means not exactly 0. It's low and high. Take it as low and high. So if the target output was 1 high, but the actual output you are getting through computation is very low, then we have to increase the weights. We have to repeat this algorithm until no more mistakes in the sense no more deviation between the actual output and the target output. Got it? Got it? Clear? This is what perceptron algorithm. Clear or not? Everyone? So we will be starting with random weights. Then we will be computing the output for perceptron. That is our training phase. Then we will be comparing it with the correct, target output and the actual output. If the target output was very low and our actual output is very high, which means we have to decrease the weights, vice versa. Right? So this is until no more mistake, no more errors, we have to repeat the steps in the algorithm. This is the algorithm for perceptron. Okay. So first, the same person, Rosenblatt, was implemented this algorithm to classify the shapes. We have different shapes, right? Shapes in the images. We collected different shaped images and implemented this algorithm so that the machine learning was initiated. Got it? Here, the first implementation for classification of shapes. So that the machine learning was initiated. Okay. So we have seen about the perceptron, right? Simple perceptron. What happens when there is a need for multiple categories? That is what perceptron for classification with multiple categories. So that based on this need, multi-layer perceptron was developed. Right? So arrange multiple perceptron in a layer. We can have input layer, different hidden layers, right? So arrange multiple perceptron in a layer. So we have to create a model with multi-layer perceptron, right? So we are going to create the first one. So arrange the multiple perceptron in a single layer. So this is for classification with multiple categories. Okay. So arranging multiple perceptron, then receiving. If we have any number of perceptron in a single layer, all the things will be getting the same inputs, and each and every one will be considered for calculating the output function. Got it? So this is what classification based on multiple categories. Multi-layer perceptron was developed. In 1969, Morton, Weinstein and Seymour Burbach have written a book named Perceptron, a rigorous analysis, which is the first development of elaborative book about the perceptron, which includes simple perceptron, multi-layer perceptron and its applications, some of the initial application and its limitations, everything. So based on his book, the thing is why there is a need of multi-layer perceptron, there is a need of multi-layer network presence. So in order to solve very complex problems, in order to solve complex functions or complex problems, for example, to learn about hexagonal neural network, we are in the need of multi-layer perceptron. Right? Next is to show the multi-layer neural network. there. So that the back propagation algorithm was developed in order to eradicate that disadvantage. Got it? So he developed the multi-layer network. So in order to eliminate the limitation of Rosa and Black multi-layer network, the back propagation algorithm was developed. Right? So this is the basics of perceptron, multi-layer perceptron and the evaluation of back propagation algorithm. Clear? So you know very well, right? We have seen back propagation algorithm, isn't it? Already. So what is the basic concept? Whether we are going with the feed forward flow, I mean from the input to hidden layer to output layer.
Output to
Whether we go in the flow,
output to
am I right? In back propagation algorithm.
reverse.
No. So what we are doing is, as usual, we will be taking the initial layers, we will be computing and we will be checking with the targeted output in order to eliminate the errors. We back propagate from the final layer to the previous layers. That is what back propagation algorithm will do. So starting from the output, we will try to change the weights of the previous layer. Then we will be having hidden layers in between, right? So taking the hidden layer and we will try to change the weights of the input layer, so that we will try to eliminate the error between the target output and actual output we got. Okay? Right? Clear? That is the concept of back propagation. We will see the algorithm. Take this. So back propagation algorithm for neural networks. So I already told you, right? So this is what to eliminate the errors on loss. Okay. So first thing is we will be calculating the errors in the output layer. So for this algorithm, this is not neural network algorithm, right? Neural network algorithm starts with the input layer, then it will do computation, then it will calculate the output. Now this is back propagation algorithm. How the back propagation alone works, that is what we are going to see. So it starts with the final layer, output layer. So first thing is we will be getting a value. We have a particular error value. Calculate the error value in the output layer. How can we calculate the error? Which is nothing but the difference between target and actual output. Got it? Okay. Calculate the errors. So, taking from the initiating at the last stage, from the output layer, propagate these errors backwards to the previous hidden layer. And if we are going to propagate to the previous hidden layer, where we are going to update the weights of the previous hidden layer. Once we are updating a particular weight, means it will have some kind of reflection in the output, right? Am I right or not? So this is input and this is weight. Suppose we are updating this as 0.3 means that will be an updation in the output also, right? So that we error will be changing, right? Am I right or not? So by propagating back to the previous hidden layers and by updating the changing the weight, errors in the output is also will get changed. Okay. So for this, in order to update this weight, we are going to use a best optimization algorithm in order to find out the updated weights in the layers. Right? So in order to update the weights in the layer, a perfect or best optimization algorithm will be used so that finally we will minimize the error. That is the difference between actual and the target. Right? So until there is no error, there is no difference, we will be doing the back propagation again and again. Right? Clear? First, it will take starting from the output layer. propagation. So in 1960s itself, they have many papers, many research papers related to back propagation arises, but at 1970 only the ZEPO first created a concept about back propagation, and which was originally implemented by a first thesis in 1974 by Paul Gauss. And in between 1974 to 1986, there were a lot of research was, but in 1986, a group of persons created back propagation algorithm, created a paper called representation by back propagating algorithm, which has a clear view of back propagation algorithm and its applications and its limitations. Got it? Okay. Then in 1989, there is a key finding that a neural network, that is a mathematical proof was created. Multi-layer neural network can able to solve any kind of complex problem. For this statement, a mathematical proof was found out in 1989. Okay, so in that time, many applications was developed, many applications was implemented using the deep learning neural networks. So initially they have used for